Hello learners, so today topic is from the sorting algorithms, one of the most popular sorting algorithms, that is merge sort and quick sort. So basically sorting is a process of arranging the given arrays of elements in either increasing order or decreasing order. So in these algorithms, what will be the input here? The input will be a set of numbers in any order. So it can be in increasing order, it can be in decreasing order also. So you can also give it the already arranged increasing order numbers, or you can also give it already arranged decreasing order numbers also. So but the end result will be that the algorithms are giving the same result in the end, but that is not our motive. So our motive is to that if you give any random set of numbers to these algorithms, they will produce either in increasing order the set of numbers or in decreasing order the set of numbers. So the input will be a sequence of n numbers, that is from a1 to an, and the output will be a permutation of reordering. You can say the reordering of these a1 to an numbers in the that starting from that in our example what we will do, will start in increasing order. So the first number will be the lowest and the last number will be the highest. So sorting algorithms are the most used algorithms in data structure and algorithms. They have a wider and similar range of different applications that I will discuss further. So first and the most popular algorithm that is widely used is called as merge sort. So everything is in the name. So merge sort means that you will first divide and conquer the list one by one, and you will again in the end merge it one by one. So merge means that in the end you will merge it to get the output. So merge sort also here use the divide and conquer strategy. It means that it will again be into three steps. The first step will be that you have to divide it, the next step will be that you have to conquer it, and the last step will be that you have to combine it. So the combination step will be referred to as a merge step. So if you see here, first step is divide the n element sequence into two sequences of length n by 2. Suppose you have 8 elements and these 8 elements will be divided into 2 sublists. So, okay, so there will be 8 elements from index 1 to 8. So first step is to divide this 8 element into a set of 4 elements. This is referred to as divide strategy. So it means that if the first index is referred to as 1 and the last index is referred to as 8, and you divide it by n by 2, so the total elements here is 8. So if you divide it by n by 2 means 8 by 2, which is 4. So what will you do? The first list will be from 1 to 4 and the second list will be from 5 to 8. So if you see here, the divide step is that the first list will be from a of 1 to a of n by 2, so 1 to 4, and the next list will be from a of n by 2 plus 1, which is a of n by 2 plus 1 will be 8 by 2 plus 1 is 5, to a of n, which is total elements, which is 5 to 8. The first step is to divide the list into two parts. If there are 8 elements, the first list will be from 1 to 4 and the next list will be from 5 to 8. The next step is to conquer. So whenever there is a conquer, it means that you have to recursively call a function. Now recursion is that the function will call itself again and again. So in this particular step, what will happen here, that you will sort these two subsequences a1 and a2 recursively using the merge sort algorithm, and then in the end you have to combine it. So merge the two sorted subsequences a1 to produce a single sorted subsequence. So I'll more discuss about this. So if you see in the diagram of merge sort here, so the list contains n element from a of 1 to a of n. So if there are 8 elements, it will be from a of 1 to a of 8. Now you divide it into two parts. The first part will be from a of 1 to a of n by 2, and the value here that is used is ceiling. So what it means is that if there are 9 elements and you divide the list, it will be n by 2. So 9 by 2 will be 4.5. So you have to take the ceil value of it. It means that the first list will be from 1 to 5 and the next list will be from 6 to 9. So that is why the ceiling value is being taken. So now another list will be from a of n minus n by 2 plus 1 to a of n. So what we are doing here is that we are dividing the list into two parts. So first step, and the next step is that you have to conquer it. Next step, it means that you have to recursively sort the list of A1 and A2 one by one, and in the end you have to merge this list into a one sorted array. So these are three steps, and this will be also discussed in the algorithm. So if you see here the example here that is being given here, that we have 9 elements. So 9 elements which have 9 indexes from 1 to 9. So they are not in any sorted order, so they are random elements. So if you check here, first step is to divide the list into two parts. So the first step, the list that is divided here is from 1 to 5 and 6 to 9, the same way. So what happens is that it will be from A1 to an minus n by 2 of ceil. So 9, there are 9 elements, so n by 2 will be 9 by 2, which is 4.5, and the ceil of it will be 5. So the list will be from 1 to 5, and then the other list will be from 6 to 9. So these are the index numbers that I'm talking about. Again, what you are doing here is you are again dividing the list further. So the 5-part list is again divided into 3-part list and 2-part list. Again, the 3-part list is divided into 2-part and 1-part, and the 2-part list is divided into 1-part and 1-part. And if you see here with the 2-part list, that where the element is 90 and 45 here, and when you are combining it, actually you are merging it. So this is the merge procedure. So what will happen here is that first element contains 80, second index element contains 45. So when you merge it, it will become 45 and then 80. Okay. So now this is a sorted list of 2 elements. Now you have to again combine it with the another index, that is 3. Okay. So when you combine it, again you have to sort it with the third index. So you check that this is 15, and you already have a sorted list of 45 and 18, and when you combine it, the 15 will become in the first index. So it will be 15, 45 and 80. Similarly, so you go and so on and so forth. You go first divide the list into 2 parts, and you do that until you only get one element with one index. Okay. So when you get the one element with one index, you just sort of merge these and sort this on the same time. So I know that this may seem silly at this point, that why we are dividing it, dividing the list one by one, and we are going to the end where only one element left, and one element itself is sorted in itself, and when we are combining it, we are just doing the sorting in the combination step. So why are we doing that in this way? Why not just when you get the list, you directly take the elements and you divide it, or you sort it rather than dividing, you sort it depending upon that. So again, if you see in the example, it may seem a little bit very difficult, why we are doing so much calculations and other things, but in the long run it will be a very good method. I'll show you how, because we have not discussed about the algorithm yet. So going into the algorithm, so these are some points that you have to keep in mind, that the first half of the example, you will see that this is the ceiling value, that where the list from 1 to 5 and 6 to 9 is being there. And again, it is going further again and again, because this is an odd number, always the ceiling value is being taken. So you took first the first list is 5 and 4, next list is 3 and 2, next list is 1 and 2 and 3. So if you take care, every time there is an odd number, and every time we are taking a sorted value. So now look at the merge procedure first. So merge sort algorithm is very, very simple in itself, but the heart of the merge sort algorithm is merge procedure. So if you look at it, what is here happening here? So what they are doing is merge, they are calling the merge procedure, where A will be that the array that you are giving it to it, and P and Q and R are the values. So A, P will be the first element, R will be the last element. Like if you have the index from 1 to 8, so P will be 1 and R will be 8, and Q will be the division of the list. So suppose if you have 8 elements, now Q will be the mid of the list, that is 4. Okay, so if they have 8 elements, 1 is P, 4 is Q, and 8 is R. So if you are looking here, what they are doing is actually you are dividing the merge procedure. What is happening, they are dividing the list into two parts. Okay, so they are copying these two parts, n1 and n2, into arrays, and now the name of the arrays is L and R. So they are calling it first left array and second right array. If you look closely in the step after the second step, there is n plus 1. So what they are doing is that if suppose there are 8 elements and you are taking these 8 elements and you are dividing it into 4 elements. So the list, the array that you will form here first with first 4 elements, what they are doing is that they are not taking 4 elements, they are taking 5 elements. Similarly, in the right hand side, they are also taking one extra element that is not in the list. Suppose that you have 8 elements, the left list will contain 4 elements and the right list will also contain 4 elements, but they are adding one extra. So the left and right list will contain 5 elements total, and the fifth element will be set to infinity. Okay. So in the next step, what they are doing is that they are just copying the elements into left and right array, and they are setting the last element of left list to infinity and last element of right list is infinity. Okay. So now what they are doing is this, simply they are comparing the elements one by one. So what do I mean by this is that they are taking the two list, there are two pointers, suppose one pointer is I, another pointer is J. So I is at the left list, J is at the right list. So what they are doing is that they are just taking a comparison one by one. So they are comparing I pointer with J pointer. Suppose we have I here 12 and J at value J 14 is being stored. Okay, so what is happening here? So I is compared with J. So if you see here, 12 is less than 14. Okay, so left and right list, first element will be compared. So 12 is less than 14. So what will happen here? 12 will be placed in the merged list and the pointer is incremented in the left list. Suppose the next element here is 15. Okay, so now 15 is greater than 14. So what will happen here? That 14 will be placed in the combined list, in the end list, that we will do the merge part, and the pointer of the right list will be incremented, and so on and so forth until both the pointers will reach at infinity. Okay, so this is the heart of merge sort. This is referred to as a merge procedure, and this merge procedure will be called recursively again and again. Okay, so if you check, the algorithm itself is very simple. Suppose the algorithm is merge sort. This is taking list, the first element and the last element, and if it is saying that if P is less than Q, so what it means is that if you have 8 elements, because you are calling it recursively again and again, so suppose first there are 8 elements, so the P will be 1 and R will be 8. Now 1 is less than 8, that is fine, but when you divide the list recursively again and again, so the next time, for the next time, the P will become 1 and the R will become 4, and again if you divide this list again from mid, so the P will become 1 and the QR will become 2. So what is happening here? You are taking a bigger list, you are again taking recursively the smaller list and again taking the smaller list. So if there are 8 elements, then you take those 8 elements and you take the mid of it, so it will become 4 elements. So from 4 elements, you are again taking the mid of it, it will become 2 elements. So here the P is 1 and the R is 2. Okay, so you have to do it until and unless the value of P is less than R. So what happened here, when P is 1 and Q is 2, so when you divide it again, it will this particular statement will not be true, because the value will be in you have to take either ceil or you have to take either the floor. So the value will it becomes equal to 1, and then the division is not possible. Okay, so that is this condition if P is less than R. Now the next step is that you have to find out the mid here, that is your becomes your Q, and the mid will be the ceil value of it, that the floor value of it, that is P plus R divided by 2, and you have to call it the merge sort A, P and R, and then again the merge sort is being called from the first list, and the merge sort is being called on the next list. So if there are 8 elements, you divide it into 4. So the merge sort is called in this list, and the merge sort is again called recursively on the next list. And in the end, you are calling the merge procedure that we have already discussed in the previous slide. Okay, so now check the example here. It will be easier if I show you the example. So this is how the merge procedure works. If you're seeing here what is happening here, first you take 1 to 7 elements here. So when you are doing a merge procedure, what will you do? You divide it by half and you take the ceil value of it. So this is 1 to 4 and 5 to 7. Yeah, so these are two lists. Okay, so from 1 to 4 and 5 to 7. So if you are seeing here in the algorithm what happened there, it is divided into two lists, L and R. So if you see here, there are 2 pointers, I and J. You check here that the left list and right list, when you compare it, 20 is greater than 10. So what will happen? The 10 is placed in the merged list, 10 is placed in the last list, because we are sorting this, and we increment the pointer. As you can see, 10 is placed in the merge and we increment the pointer J to 50. Similarly, 50 is compared with again I. Now here the I is lesser as compared to 50. So 20 will be placed in the merge list and 20 will be placed in the merchant, and pointer will be incremented. Okay, so if you check here, again it will be 10 and then 20, and then again compare I and J, which is 30 and 50. So 30 is less than 50, so 30 will be placed, and then incrementation. Okay, so when you place it, you have to increment the pointer. Okay, so the pointer here is at 40 and it is compared with 50. Again the I pointer is less, you place the 40 in the merge list and increment the pointer to 70. So now 70 is greater than 50, so 50 will be placed in the list and the J pointer is incremented to 60, and in the end the 60 is less than 70, so 60 will be placed in the list and the pointer will be incremented to infinity. Yeah, so 16 placed in the list and the pointer will be incremented to infinity. So infinity is always greater than 70, because infinity is a big number. So infinity will be greater than 70, and when you compare 70 with infinity, so 70 will be the answer. So to place it in the end, you can place 70 in that. Okay, so this is how your merging procedure works. It's very, very simple. And another one is how this merge sort will work. Okay, so merge sort is again very simple. You take the list from 1 to 7 elements. Here the floor value, ceil value will be taken. So 7 is 3.5. The Q will become again 7. So there are 1, 2, 3, 4, 5, 6, 7 elements. So 7 by 2 is 3.5. So floor value is taken as 4. So you divide this list into 1 to 4 and 4 to 5 to 8. You are recursively calling the merge sort function from 1 to 4 and 5 to 8. Okay, so check here, the merge procedure is very, very simple. If you look here, that we are calling it one by one. So if you check the algorithm 3 step, the first step was you're dividing the list, and then you're calling merge sort, again calling merge sort on the other part of the list, and in the end you're calling merge procedure. So if you look at this example here, 70, 20, 30 and 40 are two lists, 10, 50 and 60 is another list. Okay, so divided, first step is to divide it. Now merge sort is being called on A 1 to 4 and 5 to 7. After that on this list 1 to 4, because there are 4 elements, so it will be again called on A 1 to 2 and 3 to 4. Okay, and again it is called on single list, that is 70 1 to 1 and 2 to 2. So because if you see here that this particular in the end you are dividing the problem so small that you are in the end getting a single element. Now what you are doing is you are combining the list. Now how will you combine? Combine it with the help of a merge procedure. So now what will happen here? Infinity 7 infinity, 70 infinity and 20 infinity will be placed at this step. Now again I and j pointer will be there. So you compare 70 with 20. So I is greater than 20. So what will happen? Increment the pointer of 20, or place the 20 here and increment the pointer of j to infinity. Okay, and then infinity is compared with 70, which is again 70 is less than, and then okay, so on and so forth. This particular step is being performed when you are merging the list. Keep that in mind. So if you check here, when you are merging the list of 20 to 70 to 30 to 40, so what will happen? Again infinity will be placed at the both of the end, because this is the merge procedure. Now the 2 pointers I and j, I will be placed at 20, j will be placed at 30, and what will happen? Compare I with j. So I will be lesser than j. So you will, what you will do? 20, place it, increment the pointer to 70. Again what will happen? J is at 70 and so I is at 70, j is at 30. Again compare it, 30 is lesser. So again place 30, move the pointer to 40. Now 70 is compared with 40. Now again 40 is there. So 40 place, increment the pointer to infinity. Now infinity is compared with 70 and then 70 will be placed. So this is how you go so on and so forth by combining different elements. Okay. This is the example, and this is how merge sort is actually being done. So if you look at the complexity of the merge sort here, just look at what happens is that when the list is greater than 2, it is dividing the list into two different parts. So division part is that you are dividing the list into two parts. Okay. So what they are doing, recursively solve sort, you are saying we are dividing the time we are multiplying it by 2 and we are dividing the list by n by 2, and after dividing the list you are doing a constant task of merge procedure. So if you see, the equation will become that 2t n by 2 plus constant, or you can say theta of n, if n is greater than equal to 2, but when there is one element you do not have to do any work because it's already insorted. So theta becomes 1. So this is a constant work if the element is only 1. Okay. So by master method, if you solve this, the complexity for this case becomes n log n. So this is by far the best complexity you will get it on merge sort. So if you solve it by master method, there is another method by forming a recursive tree, but master method is much simpler, and you take the recurrence relation here and you plug in the values and you just take the master theorem and then you apply it, you get the complexity as n log n. So this is by far the best complexity you will get in the sorting algorithm in merge sort. Similarly for quick sort, quick sort is very similar to merge sort in again the divide and conquer nature. And there are other cases also. So here quick sort, there is something called a pivot element that is being introduced, and there is also the heart of the quick sort algorithm that is referred to as a partition merge. In the previous one we have merge procedure, here we have partition procedure. Okay. So here the worst case complexity is actually being n square, that is again worst case, but the best case and average case complexity here is n log n. So again it is it's a very good algorithm if you check the best and average case complexity, but if it is the worst case, then it becomes equal to another algorithms like insertion sort and all those other algorithms. Okay. So quick sort is again based on the same thing, that you have to divide the list into two parts and then you have to conquer it, means that you have to call the procedure on those two lists recursively and then you have to combine it. Okay. So you check the partition procedure, that is again the heart of the quick sort. If you check it, what is happening here is that they are taking two lists one by one, and then they are comparing it with the pivot element, and when it is less than that pivot element, what they are doing is that they incrementing one pointer I and they are exchanging the value, so on and so forth. So I'll tell you that it's difficult to understand from this particular procedure, but I'll show it with the help of example. So again, the algorithm of quicksort is itself very easy. So if very similar also, if P is less than R, so P and R again, if there are 8 elements, P will be 1 and R will be 8. And if P is less than R, then what you do, you apply the procedure of partition, and because you have partitioned the list into 2 parts, and then you are calling quicksort on one part and quicksort on another part, same thing. Okay. So if we check here, the partition part here, how the partition procedure works, suppose this is the example. So here there are 8 elements. So what you have to do, you have to select a pivot element. So pivot element mostly will be selected at the end of the list. So we are calling the pivot element as R. So it is denoted by R. So x a of R is equal to 4. So at the element at the index 8, the element pivot element R is being selected, which is 4. So what we are doing, there are 2 pointers I and P. So I is not it's not being started, so it means that it is index at index -1, or you can say index 0, and P is will be started at the index 1. Okay. So now what you have to do is you have to take the pivot element and you have to compare the R with P. Okay. So now this is the simple procedure. 4 with 2. Always remember in these algorithms, always respect the elders, and if they are the smaller elements, then you have to take action. Okay. So this is simple mantra, that you always have to respect the elders, means you have to respect the bigger value and you have to take action when the value becomes smaller. So what will, now compare 4 with 2. Now 2 is less than 4. Now 2 is less than 4, which means that it's a smaller value. Okay. So when there is a smaller value, always take action. So what is the action here? Increment the value of I and exchange it. Okay. So when you increment the value of I and P lies on the same pointer. So when you exchange the value of I with P, it is 2 exchange with the 2, which is 2. So you do not have to do anything. So everything will be same at this step. Okay. Now again move forward. The next pointer P will again incremented after the exchange. So now R is being compared with 8. Now because 8 is bigger than 4, so always respect the big numbers or always respect the elders. You don't do anything, don't take any action. Again increment the value of P. Now when you increment the value of P, 4 is again less than 7. So again it's a big number, respect the elders, don't do anything, increment the value of P. Now here, now when you increment the value of P, it will be 1. So 1 is less than 4, so it's a smaller value, it means you can take action now. So what will you do? Increment the value of I to 8. Okay, so it is standing at 2 now, so it will be taken to 8. Yeah, and your P value will be standing at 1. So exchange those value. So 1 will be placed at where I is there, and 8 will be placed where P is there. So 1 and 8 will be exchanged. Okay, so you can look at it in the slide. Now again increment the value of P again. So 3 is again less than 4. So again it's a smaller number, you have to take action. So what is the action here? Increment the value of I and exchange it with P. So what is the, when you take the increment the value of I, it will become 7, and it will become 7, and then what is the value of P? So value of P is 3. Now you exchange 7 with 3, so it will become, the list will become at index 3 there will be 3, at index 5 there will be 7. Now again increment the value of P. So 4 is again greater than 5, don't do anything, respect the elders. Again increment the value of P and it will be at 6. Okay, So again, don't do anything because the value of 6 is greater than the value of 4. Okay. So now in the end, if you check here the value at p, which is at 6, now you can check the last step is that you have to wherever the value of I is. Now where I value is at standing at 3, okay, at index 3. Now when the whole list is being scanned and the value of p has reached at the end before the pivot element, so what you have to do, wherever the value is, you have to just quickly swap the values of pivot element with I plus 1. So if we check here where our index is 3, so 3 plus 1 index is 4. So at index 4 the pivot element will be exchanged. So it will be 8 will be taken to the pivot element and 4 will be taken to the 4th index. Now if you check here, you take that this pivot element that we have selected is being sorted. Okay, check at the left of it all the values that are smaller than 4 will be there, and at the right of it all the values that are bigger than 4 will be there. So this is how the procedure works. Okay, the partition procedure works in this case. So the quicksort complexity, if you just take care of it, that if you take the recurrence relation, it is very close to merge sort, and again the best case will be that it is divided from the mid. So if it is divided from the mid, it will become merge sort, very much close to merge sort, and it will be the best case. So the complexity also becomes close to merge sort, so it will be n log n. The worst case will be that if you are already given a sorted array, so you have to perform the procedure one by one, and in the end you will get the same result. So that is why the worst case here becomes n square, so which is very close to insertion sort, selection sort, and other kind of worst cases. So the average case mostly it will be n log n. So that is why this is being why it's called quick sort, because the pivot element is quickly sorted within the list. Okay, so that is why. But if you recursively call it quick sort on every element will be sorted recursively, and in the end, if it is a best case, you will get the complexity of n log n. Okay, so this is how your most popular quick sort and merge sort or sorting algorithms work. And in the next one, we will see about integer multiplication and Strawson's matrix multiplication. Thank you.